This video will cover not section, but investigating polynomials. And so we started by writing a definition of a polynomial. So a polynomial is one monomial or more than one monomial. So we could have two monomials, three monomials, four, and even more than that. The first example we have here, that is one term only, even though we have x and y. The fact that they're not adding or subtracting, that tells us that it is only one term, and because it is one term, we call it monomial. The next one, we have two terms, and we know that because there is a negative sign in between them. So when we have two terms, we call that binomial. The next one, you guys could see we have three terms, 1, 2, and 3. And so for three terms, how do we call those guys? Trinomial, very good. Okay, the next one, we have 1, 2, 3, and 4. So whenever we have 4 or more, we don't really have a specific name for them. We just call them polynomials. So whether it is a monomial, binomial, trinomial, polynomial, they all belong to the polynomial family. Oh, I'm just going to write it in Spanish. Okay, so let's talk about now about the degree of a polynomial. And to find the degree of a polynomial, we will have to find the highest degree of a monomial. Let's say of all monomials. And just as a review, the way we find the degree of each monomial we must add the exponents of all variables. Not the numbers, not the constants, but the variables. So here we have the example, a very good example. This is just a monomial, right? And the exponents of the variables, we have a 2 and we have a 3. So if we add 2 plus 3, we get 5. So that is how you get the degree of a monomial. Now, once we have several monomials, like this one, we're going to have to do some addition. That one you guys will do on your own. So, because that is the only term there, the only monomial, then the degree by default becomes just 5, the degree of the polynomial. For the next one, it is a binomial, right? We have two terms. So the term of the degree of the first term is a 2. And we're going to separate it with a comma. So the degree of the second term is a 1. So which one is the highest, a 2 or 1? 2. So that will be the degree of the polynomial. The next one is a trinomial. We have 3 terms. So we're going to have 3 numbers here. So the first term, the degree is a 2. The next one, the degree is a 1. Remember, when you don't see an exponent, you assume it is a 1, right? And what is the degree of the constant term? 0. So remember, we say 0 because those could have an x to the power 0. So which one is the highest degree there? 2. So that will be the degree of the polynomial. All right, now the fourth one, I want you to do that on your own. So remember, you're going to have to consider, you're going to have 4 numbers here because we have 4 terms. And don't forget that the letters without an exponent are of degree 1. Okay, so Alyssa with an S. What are the degrees of each monomial here?
4.
Well, we have a to the power 4 and b to the power 1, so 4 plus 1.
Oh, 5.
5.
Okay, I understand that. 3. And 2. And 0.
And 0. Okay. And which will be the highest number there?
It will be 5.
5. So 5 will be the degree of the polynomial. Yes. Yes. Make sure I get it back because I already lost one here. Okay, guys. Now what we're gonna do next is we're going to be simplifying polynomials by adding, subtracting, and multiplying. So we're going to use some properties from algebra, the rules with exponents that I still have on the board for you. So, and of course, if we're multiplying, we might have to use the distributive property. Actually, we will use the distributive property. And so we're also going to be combining like terms. So adding or subtracting, all right? So the first problem that we have here, I'm going to just set it up for you, and then you will work it out. So we're going to be adding two polynomials, right? We're not multiplying them, we're adding them. The first polynomial, this one, it doesn't have any number in front of it, so I could just clear the parentheses and not change anything, meaning the coefficients. Now my second polynomial, there is a number 2 in front of the parentheses. And so what that implies is that the number 2 will be multiplying every single term inside the parentheses here. So when we multiply a number times a monomial, what we need to do is multiply the coefficients. So we will have positive 2 times 3x squared, and that will be positive 6x squared. We don't need to do anything with the exponent. Next, we have positive 2 times negative 3xy, so that will be negative 6xy. And then we have positive 2 times negative 5y squared, so that will be negative 10y squared. Now, what I want you to do next is combine like terms. So remember, like terms are terms that have the exact same variable with the exact same exponent, right? Okay. So I'll give you a few seconds to complete that. Okay. Mikhail. So what do you get for the x squared? So we have negative 4x squared, positive 6x squared.
2x squared.
2x squared, good. So Mikhail here, he combined the coefficients, right? So 6 minus 4, so that's 2x squared. Very good. Next person. I said y squared. So tell me, what do you get for the xy term?
Negative 9xy.
Negative 9xy. Very good. So negative 3 minus 6, we get negative 9. Next person will be Tanya. So now I want you to tell me what you get from combining the 5y squared with the negative 10y squared. Negative 5y squared. Very good. So we only combine the coefficients, right? And we keep the same variable. Now let's move on to the next one, and I'm just going to set it up for you. Don't worry, in a minute you'll get a chance to multiply. So the first parenthesis, same thing, is just 3x squared plus 6xy minus 7y squared. So we could just get rid of the parentheses. However, here for the second polynomial, there is a negative sign in front of the parentheses, so we need to distribute that negative sign to every single term inside the polynomial, inside the parentheses. So when we do that, the idea is that every term inside the parentheses will change to its opposite sign. So instead of negative x squared, we will have positive x squared. Instead of positive xy, we will have negative 5xy. And instead of negative 2y squared, we will have positive 2y squared. So now I want you guys to combine like terms, please. All right, Julio, what do you get from combining the x squares?
4x.
4x squared, okay. Abraham, what do you get from combining the xy terms? Positive or negative? Positive xy. So if we do combine 6 minus 5, we get positive 1, right? And let's not forget we're talking about xy's. Last one, we have AF, what do you get from combining the y squared?
Negative 5y.
Very good. So negative 7 plus 2, you get negative 5y squared. In this case, I know I told you to write terms in descending order if we just had like x's. However, here we start with the x squared, we end with the y squared, and then the term in the middle will be the one that has both x and y, okay? That will become important once we start factoring. And factoring, just so you know, it will be kind of like the reverse process of distributing. So let's move on to the next page, next set of problems. So in this case, we're going to perform the indicated operations. So we're going, and we also need to simplify. Oh, and I forgot, we also need to state the degree and the number of terms. Okay. So we're going to apply the distributive property. So the way I want you to write it down is this way. So we're going to distribute the 3xy squared times 5x squared y, and then we will do that again. I know some of you could probably do this in your head, but I'm not interested about how fast you can do it. I'm interested in how good you can do it. So that's why I wanted to write it this way. The next one will be plus 3xy squared times negative 6xy cubed. So now from there, I want you guys to multiply them. So remember, to multiply monomials, you multiply the coefficients. And what do we do with the exponents? You add them, right? So of the common variables. Okay, so let's review. Edwin, what do you get from multiplying 3x squared times 5x squared y? Don't forget that has a 1 and a 1.
15. X cubed and y cubed.
Okay, very good. And next one, Amy.
Negative 18.
Well, we have a 2 and a 3, so y to the 5th, right? Because 2 plus 3 is 5. Now we need to state, is it a binomial? Monomial? What is it? Binomial, right? And what will be the degree of this binomial? 7. And so it's 7 because if we add the exponents of each monomial, here we will get 3 and 3. This monomial is of degree 6. This monomial is of degree 7, so the highest degree is 7. Degree 7. Okay, next problem. I know that you might be very used to the term FOIL, right? So when you multiply two binomials, I know maybe you were taught that way. I just want to refresh your mind. So the F, it stands for first. So you take the first term from the binomial multiplied by the first term of the other binomial. The O stands for outer, so you take the terms on the outside of each binomial. The term I stands for inner, so you take the ones on the inside or in the middle. And then the L stands for last, so you take the last term of each binomial, so the positive 8 and the negative 3. However, that is not even a word, right? And it's not like a very appropriate term to use. So what I want you guys to do is distribute. And this is how we're going to do that. So we're going to have x times this binomial. And then we're going to have plus 8 times the same binomial. So now I want you guys to distribute the x and distribute the 8. So it will be x times x, x times negative 3, 8 times x, 8 times negative 3. And after you do that, I want you to combine like terms. Okay, Paloma, what do you get after combining the x? Distributing the x.
The final is,
Right here, this part.
oh, yeah, 2x minus 3x.
Well, we're not adding the x's, we're multiplying, so we need to add the exponents.
X to
X to
the power 2
the power 2 minus
minus 3x.
3x. Very good. Now, Ruby, what do you get after distributing the number 8?
X to the power 8.
Well, in this case, the coefficient of the x is a 1, so we will just multiply 8 times 1, but still keep the x, so that will be what? 8x. And then 8 times negative 3?
24.
I'm sorry?
Negative 24.
Okay, very good. And then, of course, you notice that the 2 in the middle are like terms, right? Yes, we all see that because they all have x to the first power. So we're going to combine those by adding the coefficients. So negative 3 plus 8, that will be positive 5. And let's not forget we're talking about x. So positive 5x. And then negative 24. Now, what type of polynomial is this? Trinomial. And what will be the degree? Degree 2, because that is the highest degree here, right? Degree 2, degree 1, degree 0. All right, now on the next one, I want you to write this down, please. That problem does not equal x squared plus 4 squared. And highlight it or something. That is a huge mistake. A lot of people do that. Even my pre-cal students. I'm not very proud of that, but they do. So what we need to do instead is to multiply the binomial x plus 4 times x plus 4. And we're going to use the same process that we did before. So we take this x and we multiply it times x plus 4. Then we take this positive 4 and we multiply it by x plus 4. So I want you guys to do that.
X squared plus 4.
For 4x. Okay. And Sebastian?
Plus 4x plus 16.
All right, very good. And of course we have the two terms in the middle are like terms. Moreover, they're identical, right? They have the same coefficient. So we could say that if we combine them, we will get what? 8x, right? So we have x squared plus 8x plus 16. So this one is a trinomial, right? In fact, since it comes from a binomial being squared, we could call it a perfect trinomial squared. And of course, the degree is 2. Now, a shortcut to multiply things like that will be the following. You square the first term, which is the x. You square the second term, which is the 4. So 4 squared is 16. And then you double the product of the first term times the second. So that is 4x. So then this becomes x squared plus 8x plus 16. And why do we double? Because we're going to get 2 of those, 1 and 2. All right? Once we start factoring, that becomes kind of important. Actually, very important. All right, now number 6, that's the last one I will do with you, and then you will do 7 and 8 within your groups. So we're going to do the same thing we've been doing. We take the 2x, and we multiply that times this binomial, 2x minus 3. Then we take the plus 3, and we multiply it times the binomial here, 2x minus 3. Ashley, what do you guys from distributing 2x here and here?
4 squared.
Uh-huh. Positive or negative?
Negative.
Negative 6 x. All right, very good. Alyssa, with the y.
Positive 6x. Negative 9.
Very good. And now we look at the two terms in the middle, and you could tell that they are opposites, right? They have opposite signs. So if we combine them, we're going to get 0. You may see they cancel. So we end up with 4x squared minus 9. And the name for this one, it is a binomial, right? But it has a special name. We call it difference because they're subtracting of squares. And in fact, there's a shortcut for this one. The shortcut looks like this. Let me just clear my board a little bit. So we take the first term, which is 2x, and we square it. Oh. And so if we square it, we get 4x squared. Now we take the number 3. It doesn't matter if you take positive 3 or negative 3, you're still going to get the same. So we take 3 and we square it. And so that gives us that 9. And then we're going to have a negative inside because we're actually multiplying positive times a negative. So that's why we get negative 9. So when we factor those, they're kind of easy. You kind of take the square root of the first term, square root of the second term, and then you make one positive, one negative. But we'll start talking about factoring next class. Now what I want you guys to do is within your groups, I want you to work on problems 7 and 8. And then we will come back to check the answers. All right, Mara. So what do you and your team do to find the area of the rectangle? Both binomials, right? So 4x plus 5. And then just tell me your final answer.
12x squared plus 3x plus 10.
Plus 10. Okay, very good. So make sure you guys check with yours. Can we get 23 because that comes from 4x times 2, that's 8x, and 5 times 3x, that is, thank you, 15x. So you combine those, and that's how you get 23x. All right, now the perimeter. Kimberly, Varela, what do you and your team do to find the perimeter?
We did 3a times 3a squared plus 2a minus 1.
Well, when we say perimeter, we have to add, not multiply. So let's go back. So this side is 3a plus 5. This one should also be 3a plus 5. And then we add the third side. So the third side we have 3a squared plus 2a minus 1. All right. So I want you we only have one 3a squared, right? So now I want you, Kimberly, to combine 3a plus 3a plus 2a. So how many a's do we get? So we get 8. Very good. And then with our numbers, we have 5 plus 5 minus 1. So Isaac, Reina, what do we get there? What do you get after combining the numbers?
1 and 10.
1 and 10?
Oh, then
Positive or negative?
I see.
No. Oh, yes. Yes, you're right. So 5 plus 5 is 10, minus 1, 9. Okay, so for the remainder of the class, what you're going to do is work on the problems that are on the back side of your paper. And you're going to work them out on paper if you want, and then you're going to turn in your answers with the navigators. So I'm going to stop the video now.